welcome to DLR Project Map by Stevie's Wonders. Voices of Stevie, Joy, Ben, Aaron, Chris and Nisa. Challenge summary. The challenge posed to us was to better understand the DLR Upgrade project in terms of how individual projects fit into the wider picture.
The DLR project is a complex web of interdependencies that spans across a wide range of geological areas. Lots of data feeds into this project, but we've identified some issues with the process, including the fact that extraction, transformation and analysis is a manual process which requires further coding in order for the data to be fully usable. We've identified gaps in the data, misalignments across files, and the need to apply additional logic for the risks to be correctly impacted. The P6 data is not resource loaded and no cost implications are available, and there's no system integration with Power BI, which means that data isn't represented visually, making it difficult to interpret. TfL project managers need to be able to understand how their specific work contributes to the overall success of the project. They also need to see how other people's work relates to theirs for improved decision making and communication. Senior PMs need a quick way to visualize data across the project and identify items on the critical path with low or no flow, which may require additional resourcing.
So some of the pain points identified by TfL staff revolve around a lack of understanding of how their work affects different areas of the programme and project in terms of technical deliverables and how it relates to geographical locations, as well as not being able to realise their significance. Our approach to addressing these pain points has been to visualize risk data, location data, and P6 data for a clearer image, as well as utilizing Power Automate to keep employees notified on the progress.
The main assumptions are that activities may have multiple dependencies and resources. Any activity with blank start and finish dates are milestones with duration of 1 day. There's no detailed scorer matrix for assumptions. We have categorized these in a linear fashion. The main route for the DLR program is represented visually. However, there are other sites of interest which are also presented separately from the main diagram. The source documents sit in a central location so they can be integrated into Power BI.
Data was generally of low quality, with up to 1,000 lines of data requiring cleansing, which we complete within Excel and Power BI. Once complete, we're able to build meaningful relationships between task IDs and project IDs and geographical locations. We were also able to attribute activities such as project managers, project engineers, and resource rates to provide a realistic and real-life scenario. Measures such as total float, duration, and resource costs were also attributed, and GIS data was generally sufficient and of good quality, allowing us to provide a dynamic and interactive visual.
To create the dashboards, we used a variety of tools. These tools included Microsoft Excel, Power Automate, Power BI, as well as the P6 original dataset from TfL.
So this is the first slide of the dashboard, and it contains a geographical overview and breakdown of the risks associated across the whole project. You can filter by date and get a better understanding of where you need to focus your attention to by a colour coordinated map, as well as non-location specific projects in stations and infrastructure. These elements can then be clicked upon to drill down into what's your category account, and if we were to have the weightings of each risk, then this matrix would be displayed here for each individual project. We also have the work breakdown structure. This is a great way to look into who is accountable for each project and what their work IDs are. And this has a breakdown of both float and duration. So you can look in for what project you want to see, who's associated to it, both project manager and project engineer, and what their work IDs are.
Here we've provided you with an interactive dashboard that incorporates time, cost and schedule. We've used a matrix structure to allow you to move down and up the WBS structure. We have used a interactive and intuitive relative filter that allows you to filter by month in the next period or in the previous period. We've also incorporated some slicers that allow you to therefore filter critical tasks within each individual schedule. That allows the project manager to have a deeper dive into the project and look into more meaningful and urgent parts of the programme.
To incorporate geographical data into our dashboard, we input location data into Google Maps to make an area map of the site. File conversion of this map needed rendering to allow easier integration with Power BI. By linking this area map with a risk score, we could view the risk of projects being affected on different areas of the site on the dashboard itself.
We have used Power Automate to push risk notifications to the responsible entities. On the left of this slide, you can see the logic of how this flow works. It reads through the risk register data, then the information goes through a loop to be filtered by a condition, which in our case is whether the risk has been identified as a high risk. This information then gets sent to the risk owner via email. By using dynamic content, we are able to ensure that the correct owners are identified. This automation is involved in making sure our risk registers can be easily plugged into Power BI for reporting purposes. By following the logic, the file is copied and placed into a new destination for archiving purposes.
Future work we plan to do was create a legacy document which would act as a baseline, allowing changes to risk and schedule to be identified. We would feed this information into our Power Automate email system to alert not only the delayed project owner of the change, but also contact project managers of items dependent on the original work package, helping to streamline the change control process. We would also look to improve the data, not only by refining the existing data model, but by inputting more granular detail into the risk reporting, such as weightings and probabilities to allow for the use of confidence intervals. We'd also look to input more additional data at the lowest WBS level, including resource-loaded scheduling data, commercial procurement, market temperature data, and weather predictions, all of which should enrich the outputs of the dashboard.